Okay, so this video is about the epsilon-delta definition for left and right limits. Now, everybody loves left and right limits visually. I think they make sense on a graph, coming in from the left, coming in from the right. It's all good. How do we make sense of that with algebra? And the only thing you got to keep in mind is that we are changing the expression for one-sided limits. For one-sided limits, we change the expression 0 less than x minus a less than delta. 0 less than x minus a less than delta represents an interval, like a bunch of numbers on the number line. What does it represent? It represents all numbers that are within delta of some value a. So here's a, and we're looking at all numbers that are fit between a plus delta and a minus delta. Not including a itself. So this is what the 0 part does, 0 less than. It makes kind of a hole at 0, but other than that, we're looking at all the numbers from a minus delta to a and from a to a plus delta. So that's what this represents. 0 less than x minus a less than delta, but the absolute value, represents this interval a minus delta to a plus delta. So we're talking about x values that are close to a but not equal to a. We want to replace that with the one-sided interval. So we're just going to replace, whenever we see this thing, we're going to replace it with, what are we going to replace it with? We're going to replace it with an inequality that represents this thing. So for the limit from the right, we're going to replace it. This is going to get replaced by something that represents a to a plus delta. You could write that in interval notation. X is in a to a plus delta. Or you could write it as an inequality. A is less than x is less than a plus delta. Or you could even subtract a from everywhere. So you could say 0 is less than x minus a is less than delta. All these three things represent the same thing, and they represent this right interval that x is close to a within delta, but also a little bigger. That's what this represents. So to get the definition, the epsilon-delta definition, we take the regular epsilon-delta definition and we just replace it with this. We replace some of it with this stuff. So let's see what that looks like. For all epsilon greater than 0, there exists delta greater than 0, so that, or so, here you would normally write the thing with the absolute values. But instead, I'm going to write it like this. 0 less than x minus a less than delta implies absolute value of f of x minus L less than epsilon. Look, the epsilon got deleted over here. So this is exactly what the limit as x goes to a plus means, the right limit. We've just taken the ordinary limit and we've replaced out this interval over here by the interval of numbers just containing things to the right of a. Okay, what does that look like? So let's do a function. I don't know, let's do a function like this. Function like that. And we're talking about someone makes the green zone over here, and you're looking only at points that are near the function, but in a little bit to the right. That's what we're doing. Okay. That's the limit to the right. The limit to the left is going to be the same thing. The left limit. The left limit. And we're going to have on the number line, we're going to have a to a minus delta. A to a minus delta. We want all those points, not including a or a minus delta. So it's this interval. So that's x in a minus delta to a, or as an inequality, a minus delta less than x less than a, or minus delta less than x minus a less than 0. So that the thing I did for before, that was the right limit. Right limit. The right limit. Limit as x goes to a plus. Dot, dot, dot. This is the left limit. Limit as x goes to a minus. Dot, dot, dot. Okay, let's do an example. Let's do the limit as x goes to 0 plus of absolute value of x equals 0. And so what this means is for all epsilon greater than 0, there exists delta greater than 0. So 0 less than x less than delta implies the absolute value of x minus 0 less than epsilon. That's what it means. Okay, so we're given epsilon greater than 0, and we want to show that this stuff is true. That we can find delta so that absolute value of x less than epsilon whenever 0 less than x less than delta. Okay, so let's try to do it. And as always, we're going to work backwards. Absolute value of x less than epsilon. That looks silly because it is silly. The absolute value twice is the same as the absolute value. Okay, and we want to get to 0 less than x less than delta. Oh, with no absolute values. And so here is where the sandwich property is going to come in handy. Absolute value of x less than epsilon, that's saying x is between epsilon and minus epsilon. This is sandwich property. And now I want to say that you're between minus an epsilon and epsilon whenever you're between 0 and delta. And this works because you can shrink the interval down. So you can go like this with a one-way arrow and say x is between 0 and epsilon. If you're between 0 and epsilon, then you are definitely between minus epsilon and epsilon. That makes perfect sense. And to go from this line to this line, that will work out as long as we set delta to be epsilon. So if you set delta equals epsilon, it all works out. So maybe what's tricky about these things is because the last line, there is no absolute value, you're going to have to use the one-way arrows in the right way to make things to get rid of the absolute value. And we've seen that before in our lemmas, but just keep in mind that. Okay, next up, we're going to combine everything. So we've done left and right limits. We've done limits at infinity. You can combine them all. That's going to be the next video.